Okay, so what if we want to find a unit vector? So a unit vector in the direction of vector v for any non-zero vector v. Then we can find the unit vector based off of the vector v over the magnitude. Okay, so this will be the unit vector that has the same direction as v. And of course, doing those crazy things them kids are doing today in algebra, right? You can solve for v, and which would be the magnitude times the unit vector. So let's say we want to find the unit vector of this vector v. So once again, the unit vector is the vector v, which we have, and then over the magnitude. So we need to first find the magnitude. You remember how? Sure you do, right? You take and you square la 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 la, and that'd be 16 plus 9, which would be 25, so the denominator's 5. So I simply just write the top minus 3j over 5. And now I can split these up as 4/5 in the horizontal direction, and then minus 3/5 in the vertical. All right. Now, if you're wondering, is there a way to check that? Well, yes, there is, because what's a unit vector? A vector that equals 1. So if I check this by simply checking my magnitude, so negative 3/5 squared, and if I square this out, I get 16 over 25 plus 9 over 25, which is 25 over 25, which is 1, and you square root that, you get 1. So that makes us happy. All right, if I can get this to click, velocity vectors. So a vector that represents speed and direction of an object, such as a ball thrown with an initial speed and an angle. So we have velocity vectors. And then we have force vectors, where you put a force upon something, you're pushing something. And these represent the direction, and then of course the amount of force acting on the object. So find a vector from its direction and magnitude. Suppose you are given the magnitude vector of a non-zero vector and the direction angle. Okay, so you have an angle that's between 0 and 360 degrees between my vector v and then of course my horizontal vector. So to express v in terms of the magnitude and a scalar, my scalar being my angle, first find the unit vector, and then having the same direction. And so that's what we just did, is we found the unit vector. And then what I can do is I can simply write this now as if you notice the last one we said, well, is the magnitude times this unit vector. Well, in this case, if we're going in the x direction, that would be my cosine, and then my vertical y direction would be my sine. So this gives me how I can find a vector from its direction and magnitude. All right, so we're going to do it. So let's get my colors going here. So it says a ball is thrown with an initial speed of 25 miles per hour in a direction that makes an angle of 30 degrees. Express the velocity vector, so up in the upper right hand corner, in terms of I and j. So again, my horizontal and my vertical components. What is the initial speed in the horizontal direction, and then the vertical? All right, so if I kind of draw this out to see what I'm looking at, and let's get another color. Let's try this blue. And so of course I'm going along here. Yeah, I can't stay in between the lines either. And then here, not really looking like 30 degrees, but pretend. And then of course the speed magnitude is 25. Okay, so the initial speed. So I can find the magnitude of the vector. There it is. It was given. Is 25 miles per hour. And then, of course, alpha is 30 degrees. So all I have to do is plug all this into the formula in that upper right-hand corner. So, which would be 25. And then the cosine of 30 degrees would be the square root of 3 over 2. Plus the sine of 30 degrees, 1/2. And then typically you separate these to write your vector with the I component and the j component. So I'd have 25 square roots. I don't know what happens when I do that. Of 3 over 2 plus 25 over 2. And so this piece is my horizontal component, and this piece is my vertical. And if you just take 25 times square root of 3 and divide by 2, you should get 21.65 miles per hour. And then the initial speed of the vertical, 25 over 2, you should get 12.5 miles per hour. Okay, so that's the horizontal direction and the vertical direction. All right, one last thing in this section is find the direction angle, alpha. So if I want to find the direction angle, once again, I can draw a nice little picture. Well, I don't know if it's a nice picture, but it's a picture. Let's go here. And then, of course, I'm at, say, 1, 2, 3, 4. And then it's negative in the vertical, 1, 2, 3, 4. So in other words, I've gone all the way around to here, and I want to be able to find that angle. Well, if you look at this, once again, remembering our wonderful trig functions, and I have an x direction and a y direction, and remember something about a tangent? So I could do the tangent, which would be my y over my x, which would be -1. And looking at the unit circle, that would be at 315 degrees. All right, now after this isn't all of vectors because there's a lot of big, long, drawn out examples. So we're going to do a bunch of applications. Stay tuned.